So for the discussion section, you should describe how the data relates back to your initial hypothesis and your objectives. Provide logical arguments explaining what the results mean and how your data relates to the hypothesis laid out in the introduction section. Does your data support your hypothesis? If not, give an example of what might have resulted in your data, what could have been improved on if the experiment was done again. Address any errors in your protocol. For some helpful hints, you should have an annotated example to help guide you. Notice that it goes along with the sample annotated paper. But here are a few additional instructions. The first paragraph of the discussion should reorient your readers back to the broader context, so the optimal foraging theory. Then you should summarize the main results. Then you should connect the results back to the hypothesis, so was the hypothesis supported? Then address the broader implications of the results. So here is an example of the format that I just showed you. The first sentence reorients the reader back to the broader context. The middle section summarizes the results. And then it talks about if the hypothesis was supported. And at the very end, it addresses the broader implications of the results. So how do your results compare to other published studies? So you have to summarize the results of at least 2 studies, properly cite the studies used, and use a statement describing how your results compare to theirs. What did the other studies find? How did your results compare? Why were your results similar or different? This will provide a lot more comparisons. It'll be a lot more helpful in describing and adding to your paper. So experimental caveats and future directions. So here you should probably go back up to any problem with it, within cited literature. For instance, if birds came and hung out by the food patches, you should probably have a citation from a study about how birds might influence insect foraging. I know that some of you had spiders, some of you had flies, so just see how those might affect ant behavior. Do not make this entire section about low sample size or where you did your experiment. You can mention them, but it shouldn't consume the question. Then extraneous variables. Do not assume that if your hypothesis was not supported that you did something wrong. And don't ramble on about things that affected your experimental data or talk in excess about things that went wrong. Just because your hypothesis wasn't supported doesn't mean you were wrong or something went wrong. Often in science, it's more interesting when things don't go your way. It's more if things don't go your way, things are unexpected. It's a lot more interesting to try to describe what that could possibly mean for the field. The answer here is not always to redo the experiment over a broader area or add more replicates. It can always be done in any study, and it's kind of a cop-out. Think harder. Assume that you got your results that you would have gotten even if you had 50 replicates. This means that your results are likely correct. Using some of the conclusions from number 4, then what is your next step in the research given what you think impacted your results? What do you recommend to scientists who do a similar work? What is a new direction that you could take the general topic? And then the conclusions in the broader context. How do your results help to further understand the animal foraging patterns? Why is it important to a broader audience? And then, what is the practical application to your results? So how can humans use this information to manage species habitat, etc.? Note this last question should be a paragraph or 2, not a short answer. What do we now know about your topic that is important to research? Connect to a broader audience. So agriculture, wildlife, or habitat management, and maybe like seed dispersal. Just connect to a broader audience. And then you want to talk about when your hypothesis is not supported, if experimental design is not to blame. This is time to think about other potential hypotheses. An alternative credible hypothesis which explains your data. So a bad one is squirrel foraging activity may have influenced by heavy rains in the area. In the future, we should sample a drier time period. A good, credible alternative hypothesis is squirrel foraging activity may have been influenced by recent heavy rains with a very descriptive amount of rain. Squirrels often decrease activity and take shelter during heavy rains, with a source. Although this should seemingly affect all treatments equally, source, demonstrated that squirrels' ability to detect visual and auditory cues are dampened by rain. Thus, squirrels may not have able to detect predator cues in the rain, which would have led to a similar foraging among treatments. This is further supported by our data during day one that it did not rain, where differences between predator and control treatments were greatest twofold difference, whereas on rainy days there was no difference among treatments. This is a good explanation and an alternative credible hypothesis. You need at least 6 sources in APA format. You will likely need more than this, but at least 6. And try to be consistent. So here's the citation format of in-text citations. So one author, you just have their last name and the date. 2 authors, last name and last name, date. More than 2 authors, the first person's last name at all, then the date. No page numbers, and be consistent throughout. Common knowledge does not need to be cited. So ants are ectotherms, ants are attracted to sugar. Those facts don't need to be cited. But things that are not common knowledge do need to be cited. Notice that journal articles that you read, how many of the sentences are cited in the intro and discussion. Mostly every sentence has a citation in these sections. And then use original sources. Here is a comic. I've been reading the last draft of your paper, and you need to include more references. Really? Yes. In academic writing, every single statement must be supported by data and credited a reliable source. Says who? Me, et al. So for the point breakdown, your rough draft is worth 35 points, and your final draft will be worth 65 points. This is 100 points total, and this will be equivalent to an exam grade. I'll see you in class.